R offers 4 normal distribution functions. Today I will cover pnorm. I'll cover the other functions in other videos. $pnorm opens the help page. This is the help page for the normal distribution functions. The information inside the parentheses for each function are the function's arguments. Take a look at the pnorm function. Pnorm finds a probability, or the area under the curve. It has 5 arguments. The first argument is q. This is a value along the x-axis. The second argument is the population mean. The default value is 0, so if we don't include this argument, R will use mean equals 0. The third argument is the population standard deviation. The default value is 1. The standard normal distribution has a mean of 0 and a standard deviation of 1, so the default settings are for the standard normal distribution. The fourth argument is lower.tail, and the default is true. This means that the area that is returned by the function is the area lower than q. If you want the upper tail area instead, you'll have to change the argument to lower.tail equals false, and false has to be in all caps. If you don't use this argument, R will use the lower tail equals true. The final argument is log p equals false. In our problems, we're not going to be using the log of the probabilities, so we're going to use the default value, which means we can ignore this argument. Once again, if we do not include an argument, R will use the default value. In the first example, I used pnorm, open parenthesis 1.96, close parenthesis. Since q is the first argument in the pnorm function, R assumes 1.96 as a value for q. You could also explicitly type q equals 1.96. R returns an answer of 0.975 rounded. Since the default arguments are mean 0 and standard deviation 1, this is the standard normal distribution, so q in this case is also a z-value. This is the area under the standard normal distribution that is less than z equals 1.96. In the second example, I used pnorm open parenthesis minus 1.96 close parenthesis. R returns 0.025 rounded, and this is the area to the left of z equals minus 1.96. In the third example, I include an argument lower.tail equals false. Once again, false has to be in all caps, so R will find the upper tail area. By the way, the spaces before and after the equal sign are optional. The function returns 0.025 rounded, and this is the area to the right of z equals 1.96. Next, I'll work with 3 questions about scores on an IQ test. Test scores are normally distributed with a population mean of 500 and population standard deviation of 100. We will find the probability that a randomly selected person has a score of over 600, under 300, and between 550 and 600. To find the probability someone makes over 600, I use pnorm and put the answer in an object named ans. The arguments are q equals 600, mean equals 500, and sd equals 100, and lower tail equals false. The rounded answer is 0.01587. To find the probability that someone makes under 300, the arguments are 300, 500, and 100, using the default lower tail true, and the answer is 0.0228. To find the probability someone makes between 550 and 600, here I'm going to find the area lower than 600, then I'll find the area lower than 550, and I'll subtract the smaller area from the larger area. The answer is 0.1499 rounded. Actually, there's a simpler way to do this. You can subtract the pnorm function for 550 from the pnorm function for 600 with one operation. The statement was too long to fit on one line, so I hit return and continued on the next line. That's why the plus sign is shown in the output. It tells you the line is being continued. Thanks for watching this video. The normal distribution is at the foundation of statistics. Today we learned how to find areas under the curve. We'll be doing similar things with several different probability distributions for the rest of the semester, so understanding the logic I covered today will be important going forward. Please let me know if you have any questions.